example doesn't work. Counter example doesn't work. Any trial will fail. So now this is a tautology. If tautology, then we need to proper proof. This is a proper proof. Then there is a conjecture, okay? So please, you revise this type of things and you see how to prove. For example, 4 times a cube plus b cube is greater than a plus b to the power cube. Okay, such kind of statement you will face in the exam. You see, very nice. Just take the differences and open up, blah 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 blah. This is a product, and since a and b is positive, are positive numbers, then a plus b is positive. A minus b, whatever the number with the square, is a positive. You see, this, the right side is positive. If right side is positive, then this one shifting to the right gives the solution. So very nice, you know, the proof. This is the alternative, another type of proof they are showing. So please, you revise. This is good technique, and here's good exercise. Please, if you train with this type of examples and knowing the what does it mean contrapositives and knowing the proof of such kind of statements, you will answer the first questions in the exam very well. Okay, indirect proof, indirect proof. You see, the very nice exercise and very nice examples. Very nice examples. You see, all the nice proof. Here equality, here inequality. How to get lower bound. Lower bound. Okay? Because AB is less than 1/4. So minus AB is greater than 1/4. So that type of inequality gives us opportunity to estimate from the below. And from the below, you can see. So if a plus 1, then this statement is greater than 25/2 actually. Very nice proof. Okay, exercise. I hope if you deal with this type of problems very well, you will handle the first questions easily. Okay, what about second? Second type of problems. On the way, the rational numbers problems, I think we have in the chapter 2 or, okay, let me see the chapter 2. No, not chapter 2. The proof of the open and close. Where is the proof of square root of 2 is a rational number? Rational. I think this one. So this chapter also important chapter. So where is the square root of 2 here? The numbers, there is a rational number between them. This is the density of the problem. Rational number are not complete. Okay, are not complete. But where is the square root of 2 is a rational number. I think here. This equation has a roots. Okay, I hope we have supremum of A is B, infimum of A is small a. Completeness axiom. I think here. This is a rational number. Okay, you see, there is no rational number x such as. If you know this proof very well, then a similar problem in the exam you can easily handle. You see, rational number x such that there is no rational number. So what we do, suppose that there is, we are assuming that there is the rational number such that x squared equal to 2. It means x is a rational number. If x is a rational number, it might be written as this form. and substituting this into here, equating with 2 and shifting this 2 to the right, you will get like this. Now from here, you can see, which implies 2 is a prime of the factor a square. Therefore, 2 is also prime of factor a. You see, look, if 2, a square is 2b square, then this a is also prime factor of a. Prime factor of a means 2 times can be written as 2 times some numbers. You see, if a is a prime number, the prime factor of a, 2, then a can be written as 2m. Then raising to the square, look here, raising of the square to b square. Raising of this a square is 4m square. From these two equations, you can easily get b square equal to 2m square, which is 2 is a prime of the factor of b. So now look, if a has a prime factor of a, b has a prime factor of 2, then definitely it has the common factor. But in the, in the representation of the rational number, we say a and b have no common factor. So this is a contradiction to this statement. So that's why, so x cannot be written as a rational number for this equation. Okay, very nice and very clear, proper proof. So please learn this type of proof very well. Then you will see that in the exam. And this completeness axiom is also plays important role in many proof of the problems. You see, so the first, this one is the upper bound, is called then m is called upper bound of a, or small m is called lower bound of set a. Then what does it mean, supremum and infimum? Okay, but please, this, because over there is one more. You see, for this chapter we have two problems. One is related to the rational number problems. Second one, completeness axiom. Okay, please revise completeness axiom. I am telling you, more suitable area of the questions. You see, one chapter from matter of approximately which type of problems you can understand over there. Okay, so when you revise that one, you will completely answer the first questions. So if you revise this completeness axiom very well, understand the problem very well, then you can handle two problems here. One is proof the supremum and infimum problems. You see, I mean, in this chapter you can handle two problems. One is rational number problems. Second one, completeness axiom gives us the supremum and infimum. Okay, please properly read it and understand it. What is the supremum and infimum? You see, the b is called least upper bound or supremum of a. If b is the upper bound of a, this is the first statement. Then second one, b is greater than or equal to x for all x from a. And there is no upper bound of a, which is less than b, which means if u is also greater than or equal to x for all x from a, then u must be greater than b. In other words, so the b is called the supremum of a if there is epsilon, very small epsilon, b minus epsilon is less than x. There is x such that b minus epsilon is less than x for all x, for some x in a. You see, that there is another type of definition, but this definition also very good, proper definition. You can use it to prove how to find the supremum of a and infimum of a. You see, for example, usually we say, in this the subject, everything needs proof. Yes, we know for this interval, for any of this interval, supremum is A, infimum A, small a. Now, how to prove it? For the proof, you see, very interesting and nice proof is shown here. The proof is similar to the other cases. By definition, okay, if AB is given like this, then definitely B is greater than A. B is upper bound for this interval for A. If U is another upper bound of A such that U less than B, then look, definitely U less than B, of course, greater than A because it lies in this interval. But here, interesting point. You see, any U in this interval is less than U plus B over 2. This implies U plus B over 2 belong to the A. Or U is less than U plus B over 2. You see, the U is like this, which contradicts this. The assumption that U is the upper bound of A. You see, we are saying U is the upper bound of A, but we found that it is less than U plus B over 2. Hence, U greater or equal to B, and B is a supremum. So, okay, please learn this type of proof very well. Then you can how to actually this is the proof of the statement. But if we give certain type of functions, and say that find the supremum and infimum, of course you don't need such kind of proof. You just use that the supremum of this type of interval is B, and this for this type of interval infimum is A. You just use this statement to solve another problem. Okay, so please properly learn this topic very well, how to find the supremum and infimum. So completeness axiom is one of the important topic in the exam. So you will see, I think two problems in here. So find that then. Okay, please revise. This chapter is one of the important chapter. You can see that two questions is actually related to this problem. Okay, next. Chapter 3. Chapter 3 also have important chapter because here, you have to know very well what is the open and closed set definitions of open and closed set definitions. And using this definition, with the subset of real number, a point X is said to be an interior of E if there is epsilon. Please pay attention. This interval completely belong to the E. You see, even it's very close to the boundary point. Still, this interval is a subset of E. Whatever it is close to the boundary point of E, X plus epsilon cannot be out of the set. Okay, this is very nice and proper definitions. So this has also interior point. Now here, first of all, what is the interior point definition? And this is good exercise. Closed interval, except two endpoints. What about interior point of this? Just open interval. You see, every point X of open interval is an interior point. This one, all the points are interior except the boundary point, 2 points. So please do exercise, very good exercise we have, and revise this topic very well, because here we have two problems in finding interior, in accumulation, isolated points, open sets, closed sets, a lot of questions actually related to the chapter 3. You see? So many questions are in here. Please revise, very proper revise this chapter. Every definition, try to understand very well, and how to apply. See, example, two endpoints A and B are the only boundary points of the open interval. Why? By the definition. It's called boundary point of A if for every epsilon open interval contains at least 1 point of A, and also at least one point doesn't belong to A. That is a boundary point. You see, boundary point, and we have the isolated points. We have interior points. So you see the boundary points. You have to differentiate. I think for this chapter, I teach very proper, very clear picture we have during the class. I have given very nice picture and give a lot of examples and problems we have solved regarding to this. Please revise this chapter very well. Especially you have to differentiate. What is a boundary point? What is the isolate points? What is the interior point? What is the what else? Okay, what we have? What about an empty set? Then open set, closed set. Every point of R is the interior. And interesting point, you know, here we have the complement here, accumulation point. One more, accumulation points. Yes, exactly we have. How to find the accumulation points of the set. So accumulation point is a point, is said to be accumulation point of A if every epsilon. You see, always dealing with this interval, open interval, containing X, contains a point of A different from X. In other words, this interval contains a lot of points of A. A lot of, you see, this nice equality, you see the not equal 0, that means not non-empty. So means A contains 1 point, at least contains X, a point of A different from A. Okay, so very nice definition, and important is a formula. And this formula, sometimes we write in the form of like this. You know, when we shift this one X, not for this, for the isolated. For the isolated, now look, please. This one not equal to empty set. When we have the isolate, I think this one isolate points. Then the intersection of E with this equal to empty set, or the intersection of E with this interval equal just 1x. You see, this is very nice formula for the isolate points. You see, this is isolate points, and this is accumulation points. It looks like, you know, it looks like, look, if I remove the equality and put this X shift to the right, you see? So for the isolate points, we have equality. For the accumulation point, we have non-equality. But it is not exactly like this. Look, E intersection X minus epsilon X minus X is empty. For the isolate points, it is empty. This one is not empty. But this equality gives this equality. But this equality doesn't give A intersection with this is not equal to X. No. We cannot say like this. It can be X, except X, we have many. So that's why for the accumulation point, we should use just like this. For the isolate points, usually we use this definition. You see, E intersection with the interval, open interval, gives 1 point only. So that is a good definition. Okay, anyway, so please, I hope if you understand this topic very well, you see, there is a what we call it, intersection of the number. You see exactly this topic actually contains 2-3 important sections, questions in the exam. You see, the open sets of real numbers have the following properties. The set, empty set, and R are open. The intersection of finite number of open sets in R is open. You see, finite number. Any union of arbitrary collection of, you see, arbitrary collection of open sets in R is open. Here is R is open. This one is, but here finite number of open sets, intersection. Here any union of arbitrary collection of open sets is open sets. So very important theorem. Please you memorize and learn the proof of this theorem, then apply to the problems. You see how to find why this intersection gives only 1 point and this point. You see, it is open interval, but intersection of infinite intersection of the open sets is not open set. You see, this is a good example, or we have the counter example. So if I put instead of infinity some finite, let's say 100, from 1 up to 100, then this open set is open set. The intersection of finite number of open sets is open set, but is infinite is not open set, because 1 point is, this is isolate points. So okay, please do exercise, and this theorem also play an important role. That said, the sets empty set and R are closed. You see, just now we said it is open. Empty set and R are open, and empty set, look, empty set and R are closed. It looks like contradictions, but in mathematics everything is in the logic, right? So this is a proof of this theorem. Okay, very nice proof, because you know, union, this is C is a complement. The complement of the union, complement of the union is the intersection is equal to the what we call it, intersection of the complement of each sets. You see here union. This one we call it, what is the name of this? Do you remember what is the name of this formula? We have a name, but here they didn't state. Do you remember? Who remember the? You know, we use it, this statement. What is the name of? You see here intersection, here union. You see this complement, intersection. The complement of the intersection is the intersection of the union. You see each intersection, the complement of each C and union. One. Do you remember? Who can help?
You mean De Morgan's?
De Morgan's. Mashallah. De Morgan's formula. Okay. So please learn this proof of the De Morgan. De Morgan formulas. Okay. So please, then there is, please pay attention. I prime, if I'm not mistaken, I prime is AC is a complement. C is a complement, but this A prime is set of accumulation points. Am I right? Set of accumulation points. Prove that A union A prime is a closed set. You see, A is not closed set, but A prime together with union, A plus A union, is closed set. So very nice proof, Bolshana versus theorems. For the compact sets also we have one problem. For the compact sets, we have one more problem. Okay, so if you learn the compact sets, so you will solve the complete problem related to the chapter 3 compact sets. Okay. So what is and actually very proper definition is a Heine-Borel theorems. Actually, you see, AB be the closed and bounded interval, and G be the class of open sets in R which covers A. Then G contains the finite subclass which also covers A subclass. But you know, the Heine-Borel theorem says actually one important point. It shows, so where is the main, then connected and disconnected. I think connected and disconnected point sets. Is not there. Yeah, this one maybe we can skip, but compact is also closed. You see, closed and bounded set is a compact. Okay, actually Heine-Borel theorem says a subset A of R is said to be compact if A is closed and bounded. Actually, here it is given as definition. Actually, this is Heine-Borel theorem. In other literature, it is stated like this: a subset A is said to be compact if A is closed and bounded. You see, compactness little bit difficult to prove using this Heine-Borel theorem this way, but this way we can easily prove if A is closed and bounded, then it is compact. You see, compact contains two things: closeness and boundedness. For example, if I say A, this interval, A to infinity, is this compact set or not? How do you think? Is this compact?
No.
Okay, why no? Which condition is not satisfied?
Because it is not closed.
No, it is closed. A infinity, A from 1. You see, A including, infinity not including. It is closed set. It is closed set. But it is not bounded. You see, this interval is not bounded, but it is closed. To be compact, it must be closed and bounded. So, okay, if I say like this, A to B, but B is not included, can I say this one is compact? Definitely no, right? Which condition not satisfied? Not satisfied.
Not closed.
Not close it. It is bounded. You see, this interval is bounded, but not close it. Yes. Okay. Please exercise. So that's why actually here not many exercise. You can find from the internet the many exercises regarding to this compactness of the sets. You see, to be compact, it must be closed. This one closed, but not bounded. This is bounded, but not closed. Okay, so please properly learn this part. I think I didn't see the connected and disconnected sets problem here. You can read it. Of course, you can look at. Yeah, this one is. Okay. So, okay, what this one up to you. Okay, this one you can learn as a knowledge is good, of course, but currently we don't have any example. Okay, so the chapter 3 finish. Chapter 3 finish. Now one of the important chapter is number 4, which is sequence, subsequence, convergent, not convergent. Please, here you have to learn this. And mostly you pay attention on the example of such kind of example, which is given by two formulas. For example, is a sequence whose nth term is 1 over n. Okay, for example, if we define like this, then the resulting sequence is like this. Why it is like this? Okay, you have, if formula is given, one by one you need to derive. For example, I will derive x2 equal to what? 1 over 2, okay, 1 plus x0, 1 plus x0, x1, 1 plus x1. x1 is 0, so it is 1 over 2. You see, when formula is given, I can easily list down the elements of the sequence. This is okay. But if there are listed of the data, how we find the formula? The opposite actually is not easy. Of course, for the certain cases, we are able to find the nth term of the sequence. So in other words, so how to find for example, look, without this, if I give like this only, how can you find, you see, this is 2, 4, 8, 16, 2 to the power 8. Look, I can write according to this data, xn, I can say, look, I can say 2 to the power n here. When n equal to 1, I have 1 over 2. When n equal to 2, I have 2 to the power 2, 4, 8, 16, and so on. But how to write on the upper part to get this 1, 3, 7, 15, and so on? Actually, for this case, I can do like this: 2 to the power n minus 1. You see, without knowing the above statement, this statement, only definitely here I should write x1 is 0. Okay, x1 is 0. So if x1 is 0, then the n starting from 2, you see, you can see n equal to 2. This is, I can say this one 0. Okay, this one, x0 is 0. X1, you see, when n equal to 1, this is 1, this is 2, 1 over 2. If n equal to 2, this is 1. Okay, when 1, I have 1 over 2. If 2, 2 over 4. No. Sorry, the minus 1 is here. Minus 1, just I am subtracting minus 1 to the power n, same power n, but subtracting minus 1. You see, n equal to 1. So if n equal to 1, now n equal to 0. Okay, n equal to, okay, n starting from 0. I can start from n equal to 0. Look, n greater or equal to 0. If n equal to 0, so this is 1, this is 1, 1 minus 1 is 0, 0 over 0, n equal to 2. I have 2 here in n equal to 1. 2 minus 1, yes, correct. You see, without knowing this, I can derive, this is different formulas than this, but it is representing this. Okay, But sometimes not easy. Here I was able to find easy the nth term of the sequence, but because here the one question, then the set of problem is given, find the nth term. Okay, so please play such kind of examples very well. One is like this. If you open up, you will get like this: 0, 1 over 2. You see, this is 3 over 4, 4 over 5, and so on. This one is minus 1, plus 1, minus 1, plus 1. Now, important one is when sequence is convergent. Okay, this is the limit definition. This is the epsilon definition. Please, this both definition you need to learn very well. Then how to find the how to prove that this sequence has a limit. Okay, has a limit. How to prove it? This type of proof you need, because proof there is a proof that the limit of the sequence, for example, equal to 0. So you should learn proof of the of the limit according to the definition. According to the limit, okay, you can just calculate the limit, and if you are able to get that's okay. But using epsilon definition, not very easy. So please, you have to revise this topic very, very well. Properties of the convergent sequence, you see, and properties of two sequences, you see, properties of two sequences. All this one learn with the proof. Very good, very good. And you will find out in the exam, if you learn it, you will get easily solve the problems. Okay, so this is now monotone sequence. Yes, we have monotone sequence. How to find how to prove that given sequence is a monotone sequence? So this is a definition. You see, if xn plus 1, next term is greater than xn, so it is monotone increasing, otherwise decreasing. But this one, strictly increasing, strictly decreasing, increasing, decreasing. So you need to differentiate all this definition and apply. Monotone sequence is convergent if and only if it is bounded. You see, if sequence is bounded, then it has a limit, is convergent. Xn is increasing and bounded above, then this is the limit. Xn is a decreasing and bounded below, then the limit of Xn is infimum of the set. Okay, so please play with this type of problems very well. You see, how to find the limit of this sequence? First of all, you need to, you need to prove that this sequence is if it is increasing, bounded above. You have to prove. After that, if there is, because of Balzano-Virchow theorem, if it is increasing and bounded above, it has limit. So by that assumption, we can find the limit of this sequence. Okay, for example, for this case, it gives these results. Cauchy criterion, also very important. So here there is the one problem on the Cauchy. Okay, the sequence and this sequence and subsequence. You see, sequence and subsequence is this. This is Cauchy criterion, and subsequences. Where is the subsequence? Subsequence actually is next topic. This one, the additional. So here, this topic also you need to convergent subsequences. You see, so there is one problem regarding to the subsequences. And for example, the sequence is given, show that it is a Cauchy sequence. Or if Cauchy sequence is given, so is it possible to say that the sequence is convergent? There is one important theorem in here. So the sequence is you know, every finite has a least accumulation point of real numbers is convergent if and only. Look, this is one of the important theorem. A sequence of real numbers, please pay attention, of real numbers is convergent if and only if it is Cauchy sequence. You see, if sequence is Cauchy sequence in the real number set, then it is convergent. If it is convergent, if sequence is convergent, then it is Cauchy sequence. Actually, opposite is easy to prove. But if it is a Cauchy sequence, why it is a convergent? That one is a little bit difficult problem. But it is already stated here, and there is proper proof. So actually, here, there's some type of sequence is given. Okay, it is not stated that proof of the Cauchy, for example, criterion. No. So there is an example. So using this theorem, you need to prove. You see, if you show that sequence is Cauchy sequence, then you can say because of this theorem, it is convergent. If you know that sequence is convergent, if you're able to show that it is convergent, then according to this theorem, you can say this is a Cauchy sequence as well. So that's why please pay attention on this theorem very well and use it to solve the problems. You see, there are many good examples. You see, here 1, 2, 3. 3 sequences are given. So how to prove their convergency? So that one is not direct. You see, so many interesting estimations and equalities, then find out that it is less than epsilon. Very nice. Actually, this example is very good examples. If you analyze it, understand it, I hope you can handle all these problems. Sequences, subsequences, monotone sequences. So please, regarding to this additional one, also you need to please revise here also, you know. Here, one of the important theorem is this one, a sequence convergent to X, then every subsequence of converges. If sequence Xn converges to X, then every subsequence is also convergent to the same X, one of the important theorem. Then its convergent has a subsequence which is convergent. If the sequence is convergent, then it and has a subsequences which converges to X, then limit Xn equal to X. Okay, this one. Every bounded sequence has a convergent subsequence. You see, also important theorem. Every bounded sequence has a convergent subsequence. Okay, and bounded, if every convergent subsequence has a same limit, then Xn converges to the same limit. Actually, you know, some in many cases, if a subsequence might have limit, but the original sequence may not have the limit. So that's why if every subsequence of the sequence Xn is convergent, then the Xn is convergent too. Okay, but all the subsequences is not easy to construct and not easy to show. So the upper and lower limiters also is needed, yes, is needed, but for this part, just simple questions, you know, is divergent, why it is divergent, and while 1 over n, this 1 over n is convergent, but this Xn is divergent. Okay, such kind of simple problem you can deal, find the limit supremum and limit infimum for the following sequence. With this one, you can finish. Then no need to go too deep on this topic, because here there are many other problems. So just the beginning part, you can read it and prepare it and exercise it. I hope you will get all the questions completely. You can solve it. Okay, done. Now let me finish. If you have any questions, suggestions, you are welcome. So 62 students, okay, 61 together, including me. 62, so 61 students. Another 10 students didn't attend. I think this is a general scheme, general knowledge, and more some clarification topic. I hope will help you in the
Yes.
exam how to approach, how to focus, which topic is important. I hope you got some idea. Am I right?
Yes, doctor.
Okay. Of course, I give not the exactly the topic in the exam. So I give little bit the space of the topic. So that's why you need to read more. Of course, in the exam, you will find out some specific topic on that topic, on that general topic.
Doctor, may I know how many questions are there?
Actually, we have 4 questions.
And then we have the pecahan, is it, doctor?
So the 4 questions, and actually each questions, for example, I can say in my cases, I have 2 questions, and each questions has A, B, C. Yes. Dr. Roslan's A, B, C, D. One questions have 4. In another questions for number 4, A, B, C, D, 4. Oh, mine is ABC. In his case, ABCD. So you can imagine 4 questions. Each question has 3 sub questions, and another 2 questions has sub 4 questions. You can count how many questions we have. But of course, we are not giving the heavy problem. But every problem has specific thinking, specific approach, and critical thinking. If you revise my general topic, which I said right now, I hope you will not have big problem on the day of exam. Okay, any other questions?
Doctor, and then is there any extra time given for our submission?
Okay. This one I will discuss tomorrow with Prof. Roslan. I think 2 hours for the exam. I think another half an hour or 15 minutes we will give for submission. Yes, very good question. Please remind me tomorrow, okay? And then
Okay, doctor. All right, doctor.
tomorrow, please remind me. So I have to discuss with him how we give extra time, 15 minutes or half an hour for the submission. Yes, we should give, because if we say that 2 hours is submission together with submission may not be enough, because a lot of questions, right? Hey, please, during the time exam, you properly fill up your name, your matric number, okay? Otherwise, it will be bringing us problem, who are you? If no number, no matric number, no name, so definitely we will have problem. You can see it is under the folder. No, when we want to check inside, so we need to see at least matric number, at least. Otherwise, in the requirement of final exam, matric number must be written. Okay, please take note. Okay, any other questions?
Doctor, and then about the attendance on the day of exam, later on, doctor will give us the link, is it?
For the okay, good questions. So attendance, huh?
Yes, doctor.
Attendance. So tomorrow I have to handle 2 problems: attendance and the submission time. Okay, good.
And then we need to submit all our answers in e-learn, right, doctor?
Yes. That one is e-learning. So we will open around 10 minutes before the exam, the e-learning. Currently, it is in the hiding. So we just open. So you will submit only one file. Everything you collect in one file. Okay, and please, if you are writing because most of the time you will write handwriting. So on the handwriting, you please properly, don't rush, do properly writing. Otherwise, difficult to check for us. Okay, please, my request is to properly write the solution of the problem. Only you please, you state question number Q1A, for example, Q1B. No need to state all the problems because we have already questions. But if you say Q1A, okay, you solve or not solve. If not solve, okay, Q12, Q1B, Q1C. So this way you go down, okay? Then maybe you can come back again, question 1 at the end, but on the top you will say question 1 refer to the end. Okay, but start from Q1A, Q1B, Q1C, Q2A, Q2B, Q2C in the step. But if you are having difficulties, just skip, go to the second one, go to the third one. At the end, you will come back to the question 1, to the question 2, section 3, for example. Okay, so this way you try to manage. I think that one is for you also easy, for us also easy to understand your scheme, writing scheme. Another question?
For me, that's all, Doctor.
Yeah, usually I have one friend. Where the boy? Where are you, friend? You always give good questions. Today you're not attending? I don't remember. Anyone, I'm not asking only one person. Anyone, please, if you have any suggestion. You see, Anne already asked very good questions. I need to clarify. Additional time for submission and for the attendance. Good. For me also need to clarify. Very good. Thank you, Anne. I hope general scheme is clear, and already you are preparing for the exam, and tomorrow is the last day. If you read all the 4 chapters, now today, according to my advice, you go more specific topic and solve many problems. That is a preparation, and that's my, the help to you. So usually before exam, I give the general talk. So with you also, I'm giving today the talk. Please be open. Any questions, any misunderstanding, any suggestions, you are welcome. If not, then that's all I want to, but there is no record, of course. So far, no questions. Okay. And already left. So some students that left. Okay. If no questions, I'm going to finish also and say good luck. Good luck. I do my best. I never decrease your marks. I always positively marking. But if there is no good answer, of course, definitely you cannot get mark. But for example, if you are solving the problem at the end a little bit, making mistake, sometimes typing mistakes, I count positively. Okay. But if everything is wrong, suddenly you get the right answer. Now that one I will not take into account. You see, everything is wrong, then suddenly you get the right answer. No, it is impossible. So if you start wrong things, at the end get the right things, so you just copy from somebody. And please, in terms of copy, I advise you, don't do that, because knowledge is yours. If you are copying from others, getting the help from others, it is not your knowledge. You will fail in the future. You will fail. This type of things never help in the future. But of course, for increasing your mark, it can help. But in the future, you will fail. If you learn such kind of things, copy from others, asking help from others, that's your not your knowledge. Okay, I'm not recommend at all. Okay, so that's my recommendation. Please do your best. Bring your books. Bring your what do you call it? Lecture notes, books, computers. You can see the internet, a lot of information, because we cannot see you what you are doing, but only don't copy. Okay, whatever you can use, it is open test, you can use it, but don't copy. Okay, that's my advice. Okay, that's all. In that case, if you, I hope general scheme, everything is clear. If no questions, I just say good luck and bye-bye.
Thank you, Doctor.
Thank you
Thank
so
you.
much.
Thank you, Doctor.
Thank you for all of you coming. Thank you.
Thank you, Doctor.
Thank you, Doctor.